Alright guys, welcome to Stats. This is Chapter 2, Section 3. Fairly short video today. We're just going to be talking about stem and leaf plots. So let's get into it. So you've probably seen a stem and leaf plot before. They look kind of like this. We have our stem, which is going to have typically the tens digit or the first digit you're going to encounter from left to right on it. So here, and then over here we have the leaves, which are the kind of individual or the ones placed typically, but it can be different here. And we kind of order these one on our stem from lowest up down to the highest, and then on our leaves from least to greatest left to right. So the other thing which we need is a key for it. So for here it says, hey, 2 on the stem and 5 on the leaf means 25. So this is how we always show what the numbers actually are. So let's say I'm doing measurements of very, very small things. So all of my stuff is in decimals. So it's 0.12, 0.15, 0.27, stuff like that, right? I would put, hey, 25 means 0.25. Then all of these would mean hey, here's 3.31, here's 0.50, here's 0.46, right? All of those things, right? So the key is where you show any kind of differences in the decimals, not here individually. Now, if you have more than 2 places, so here, here is ones and tens. I just talked about decimals for being tenths place and hundredths place. If you have more than 2 places, then you would put 2 of them on your actual stem here. So I would put 0, 8, 0, 9, 1, 0, 1, 1, 1, 2, 1, 3 for stuff of that nature. You'll see one of those in the future here. So process of doing this, we want to divide our digits so that the stem, it goes from the smallest first place down to the largest first place digit. And then your leaves, you want to rearrange those left to right, least to greatest for everything that has that particular first digit in it. I'm not going terribly in-depth into how you make these because you've probably seen these at least a little bit in the past. But the other big thing is make sure you have your key or your labels that you know kind of what this is actually saying, because quite often it is going to be of different values there. Okay, so what I want you guys to do is go ahead and pause the video and answer these two questions by making your own stem and leaf plot with this particular data. So go ahead and pause and then come back. Okay, so you should get a stem and leaf plot that looks like this. So I like this one is it kind of introduces you, hey, here's how you handle when you have those 3 digits in our place here. So here we have 08, 09, 10, 11, 12, 13, and 114. Now our key says, hey, 08 means 083 or 83, right? So then 112 would be 112. Okay, here's 132. Okay, so having that key tells us, hey, that these are in the hundreds, not that these are decimals. So maybe it's 8.3 or 10.4, right? It tells us the distinction between those things. So I also like this one because it really shows you one of the big benefits, right? I can already tell what type of distribution I have, right? Because what a stem and leaf plot effectively does is it makes you kind of a pseudo histogram on its side, right? It's not a true histogram because our classes are kind of arbitrarily determined by the decimal places, but you can get a general feel for, hey, here's the kind of distribution that I'm going to actually get here. So I can see, hey, I have a big cluster here, and I kind of have less as you go down towards the 80s, and less as I go up to the 140s, which is a lot of points to score in a basketball game, but this is the data they gave. So let's just really easily see that distribution there, right? So that's the kind of other benefit. Now, you don't just do this and then say, hey, I don't have to bother doing a histogram, but I can kind of give you a little early in idea or interpretation of, hey, here's what's probably going to happen or what I should be looking for when I make my histogram in the future. So a few benefits here, like I kind of mentioned. One, it shows you your data in least to greatest, so it's already in order, right? I have my lowest, second, and then it just kind of goes order least to greatest of all of my data. So I already have it nicer from my raw data to, hey, least to greatest of that same data. Also really lets you see extreme values of it, right? So if I had like one score that was like 31, right? That'd be really easy to see here because I'd have this massive gap from my 80s down to my 30s. And I say, hey, there is that extreme outlier data point way over there, right? It also lets you see the clusters or the clumps, like I mentioned, hey, we get that big cluster here, and then also lets us see that distribution shape fairly easily as well. So that's it for 2.3. Fairly short on the homework for it, just 1 through 9. Once you're done with that, we're going to go ahead and head on to the review for chapter 2 as well. So with that, I'll talk to you guys next time.